Friends, on cantilever sheet file, the solution is to be found out by simplified approach. Let's take an example. So we take an example of a cantilever sheet pile. This is the cantilever sheet pile penetrating a granular bed having gamma prime equal to 10 kilonewton per cubic meter below the dredge line, and phi is 30 degrees, C equal to 0. And the height of the cantilever sheet pile, H, is 4 meter as shown in the figure. And the properties of the backfill is known to you. It is above the water table and below the water table. Above the water table, the total unit weight is given as 20 kilonewton per cubic meter, and this height is 2 meter. So, from the top of the backfill, the water table is at a 2 meter as shown in the figure, and phi is 30 degrees. And below the water table, gamma prime is 10 kilonewton per cubic meter and phi equal to 30 degrees. So let's draw this pressure distribution diagram. So you will have to draw pressure distribution diagram. And calculate the depth of embedment by simplified approach for the given data. So that's the problem. So this is the depth of embedment. This we need to find out. So there is going to be A, bottommost will be B, this is D, this is E. So the active earth pressure at E at this point, that is at 2 meter, PA at E, you can calculate it. What will be that? It will be K into gamma T into the height, that is 2 meter. So this becomes 2 meter. So K is going to be, for phi equal to 30 degree, the value of K is going to be 0.33 multiplied by gamma T is 20 multiplied by 2. So it becomes 40 multiplied by 0.33. So let's calculate this. (13.2 kilopascal). So PAE is known to you. So pressure can be shown. Let's calculate and plot. from here up to here, the pressure here is called PAE equal to 13.2. Right. So this becomes. Now, below this, the what? Table. So the active earth pressure can be computed. Now, we want to calculate the value at B. So the active earth pressure in a simplified approach at B can be easily calculated. Now, as you can see, it is gamma prime because it is submerged. So K gamma prime multiplied by, this is going to be 2 meter E to D plus D. So K gamma prime 2 plus D plus 13.2. So that is the total pressure at so much of kilopascal. That's there. So K 0.33 into 10 into 2 plus D plus 13.2. Right? So you can calculate this. This becomes 3.3. So this value is 3.3 into 2 plus D. This is the active earth pressure. So you have got on the active earth pressure 1, 2, 3. So what is the line of action of the active thrust? Calculate this PA and also its line of action from bottommost point. So YA bar from the bottommost point. So two things you will have to find out. So PA, therefore, the thrust, active thrust, PA will be the area of the pressure distribution diagram. That is area of 1 plus 2 plus 3. So 1, it is going to be half into base into height plus the number 2 is going to be this 13.2 multiplied by 2 plus T. P2 plus P3 is going to be half into 3.3 into 2 plus D into this height is 2 plus T. Therefore, 2 goes out. This is 13.2. This is P1 plus P2 becomes 13.2 into 2 plus D. This is P2 plus this becomes 3.3 divided by 2. You can calculate it. 1.65 into 2 plus d whole square. So this is the magnitude of PA in kilonewton per meter length of the sheet pile wall. So PA is known to you in terms of D. Now, if you want to find out the line of action of the YA bar, that you can easily calculate it. So let's do that. So YA bar, you can calculate it. So friends, if you want to calculate YA bar, will be P1 Y1 P2 Y2 plus P3 Y3 divided by PA, where Y1, Y2, Y3 are the line of action with respect to B. So P1 is already known to be 13.2 and Y1 will be 1/3 from here. So 2 by 3 plus 2 meter plus D. So Y1 is known to me. Now P1 Y1 plus P2 is already known to be. The value of P2 13.2 into 2 plus D. This is the value of P2, and Y2 will be 2 plus D by 2. So 2 plus D by 2. That is the value of Y2. So 13.2 into 2 plus D whole square divided by 2. P2 Y2. Similarly, P3 is 3 this 1.65. This is the value of P3, 1.65 into 2 plus D whole square This is the value of P3, and this P3 will be acting at what distance? This P3, and this distance is 2 plus D. Therefore, it will be acting at Y3 will be 2 plus D whole divided by 3, 1/3 of the height. So into 2 plus D divided by 3 divided by PA. So PA is this quantity. This quantity is 13.2 plus 13.2 into 2 plus D plus 1.65 into 2 plus D whole square. So this becomes YA bar. So YA bar, or this becomes equal to YA bar. So in terms of D, you get the value of YA bar. So YA bar, you can simplify it. Then what you can do it, you can just simplify it. So this quantity, everything can be simplified. So YA bar you know. Now, what about RP? So as you know, I have told you RP will be from here up to here. And here RA will be there. The force R will be there. We need not calculate this. We need to calculate the force RP. So what will be the value of RP? So RP will be equal to half into base. Base is going to be Kp. Kp is going to be 3 multiplied by gamma. Gamma is going to be 10 into D. So half into base, this will be Kp gamma D. So the pressure at the bottom is going to be Kp gamma D, and Kp is going to be 3 into 10 into D equal to 30D. So this becomes 30D. So half into 30D into D. So the magnitude is going to be 15 d square. So RP is known to you as 15 d square, and it will be acting at a distance of d by 3. Now, friends, we can take moment. We know everything. We know PA. We know YA bar. Everything is known to us. So now what we will have to do it is everything in terms of D. RP is in terms of D, right? PA is also in terms of D. You have calculated this one. So number one is PA. This PA. RP number 2 and YA bar number 3. So everything you have calculated in terms of D. Therefore, friends, now if I take the algebraic sum of moments about the bottommost point, sigma MB equal to 0 will give me PA into YA bar. This will create an anti-clockwise moment minus RP multiplied by D by 3. So RP is already I have calculated as 15 D square, which I have here from 2. So 15 D square into D by 3 must be equal to 0. So just you will have to substitute PA from expression 1, Y bar from 2, RP from 3, RP from 2, and this is 3. RP from 2, and therefore, if you solve this equation, you will be getting the value of D. So calculation, I leave it for you to do it. This is so easy in a simplified approach. Therefore, solving this, we get D. And just increase D, which you will be getting in meter, by 20%, 20 to 30%. Therefore, D required will be 1.2 or 1.3 times D. So very quickly, the problems, any type of problems can be solved. It might so happen that the ground properties may be different. Then also, we know how to calculate. Once you draw the pressure distribution diagram, then things are quite simpler. So friends, there is a problem. Finally, you need to calculate the depth of embedment, and I leave it for you to calculate it. So many problems we have done in the past, and you know that how to substitute the values and solve the equation and get the value of depth of embedment. I hope you have understood it in totality. Thank you very much.